Welcome. This is Dana Harder, Burrus Field Agronomist. And for this presentation, we just want to cover our results from our 2019 planting date study. 2019 was a tough year with a lot of growers not knowing which way to go in terms of planting and maturities. And 29 is really an unprecedented year. So looking back on this data, it might not be so typical of what we expect historically, but it does give us insight in regards to soybean maturity and planting dates and some of the responses we might expect going forward in the future years based on the weather that we encountered. So what we did for methods, looking here, we had 9 different soybean varieties from a range of maturities. Again, this trial is replicated, planted twice in Orangeville, Illinois. And for each group here in the early group, if you follow my highlighter, we have our 2.8 to 2.9. And with those varieties, we have our Don Mario Extend and Enlist lineup and our Hoblet Liberty Link soybeans, our 298. And you can tell, those maturities have bring a lot of yield in that maturity group. And there's a lot of growers who like to use that soybean coming south into Illinois to get started early and get harvest going so they can wrap up the season and then turn their attention to corn. If we look here into our mid group, which is more normal for the Orangeville area, in terms of what most growers are utilizing, you can see we have our Don Mario 3.7 Enlist, our Don Mario 3.7 Extend, and our Hoblet 384 Liberty Link, which in 2018 was our most popular soybean variety that we sold. So this just gives you a good understanding of the different technologies that we're using and the relevant soybean varieties that most growers are using for Burrus. And as we move a little bit later, you can see we have our 3.9, our 4.1. And as we move towards the southern part of our footprint, we see a lot of yield potential coming out of our Don Mario 3.9 Enlist, as well as our 4.1 P2X Extend soybean. We also have our 4.18 Liberty Link included. Now we had 5 different planting dates starting April 11th and going out to the 10th of June. It's kind of a miracle thinking back to 2019 that we're able to get all those establishment dates. But again, it's some really good data. We have some good timing intervals, and we'll take a look at the results in these next few slides. So what we first have here on this left slide is if I look at that mid-maturity group, and like I mentioned earlier, this is the maturity that is more commonly used in the Orangeville area. And we put that as a percent of maximum yield. Then on the horizontal axis, we have our planting dates. We have it regressed here. We put a quadratic regression just to see what the trend is. And if we look here, you can kind of see we saw a yield penalty with that first planting date taking place there in April. And as we get towards the end of April into late May, you can see we're about 100% of maximum yield. So we're not seeing any yield decline. We just seen it early on. As we get to that 10th of June planting date, you can see we're around between 85 and 80%, probably more like 83% maximum yield there. Now, if we look at some data that has a lot more locations this out years from Dr. Navziger out of University of Illinois, this is widely used data for predicting what the yield penalty is as we go with later planting dates. If you look here early on, you can see we're at 100%. And the penalty is a little bit more steep. We're crossing 80%, 20% yield reduction as we get to that June 10th planting date. But if we look at 2019's weather, which is unique and probably an outlier compared to what we would normally encounter, we can kind of explain what's going on. So if you think back to those last 2 weeks of April and those first 2 weeks of May, we definitely know it was cold and wetter. And here we have our growing degree days, which is a measure of thermal heat over the month of April going well till the end of June. And if we looked at this in 3 big chunks, you can kind of tell what's going on. Here, again, just to orient yourself to the graph, if we're below 0, which means we were below normal for that day, for GDDs for that day that we accumulated. If we look up here, you can kind of see that we would be a little bit warmer than usual compared to historical averages. Now, if you're a soybean planted the 10th of April and you looked out for a month, if you look at those bars, you can see a lot of those days were cool and wet. And you think about, the GDDs that we're accumulating, in terms of corn, when we're tracking that progress, you can just tell, it's taken 23, 25 days for that corn to come out of the ground. And essentially, we weren't getting any GDDs. Well, if you think about soybean, it's really critical to get to the V3, the 3 trifoliate stage, become responsive to night length, and that's what triggers flowering. So primarily flowering is triggered by night length, but the secondary factor is how fast can you get to V3 to get to that growth stage where you are sensitive to night length. So if you look here in terms of GDDs during this time frame, we're averaging about 8.2 per day, so well below the normal. Now if we look at those planting dates, if you're entering the late April, early May, you can see during this time frame a lot warmer conditions. So that's going to be a lot better for growth, getting those beans up and going. Only a few days we were negative, but as a whole, we're trending pretty well, and we made up some heat there. So if you were looking for the GDDs for the month of May, if you balance out the first 2 weeks and the last 2 weeks, that month average would tell you that you were pretty close to normal. But if you look in depth by week, you can tell that it's kind of two different stories there. Again, if you look at GDDs, we really cranked them up. We're up to 19.2, so we're above normal there. So if you think about those responses we saw, late April and those 2 planting dates in May, we didn't see any yield reduction there. But cool wet early on, you can kind of tell those beans just kind of sat there and took a long time for them to get to V3. And chances are you might have had a little bit of reduced stand as well. If we look, your June planted beans, you kind of see here we're trending below normal. But again, it's going to be lower than historical average, but we're still bringing in about 20 heat units per day. So nothing to be worried about. But again, you're not keeping pace versus historical averages for that time frame. Here we have some data for NOAA, and this is again looking at the month of May for precipitation. And one thing for the Midwest, it was definitely wet. And you look through the Burrus footprint, which is Missouri, Illinois, Wisconsin, parts of Iowa and Indiana, you can kind of see, if you look down here on the green, we're anywhere from 125 to 300% of normal for precipitation. And when you have cold wet conditions early on in May and saturated soils, you're just not going to get much vegetative growth out of those beans. So they're kind of going to be delayed, not become responsive to photo period or to night length, and you're not going to capture that advantage like you typically would. If you think about the 2018, May was the warmest month. You got those beans up and going, and many guys noticed that flowering was occurring much earlier. Here we're looking at those 3 maturity groups. Again, the 2.8, the early subset, the mid subset, which is typical for Orangeville, and our late maturity group. If we look here we have yield in bushels per acre. Our first planting date, you kind of saw this crossover. We saw kind of a yield penalty with the early maturities, and we saw the later maturities do better. As we get more towards the middle, late April into May, you can see that our yields are pretty similar, but the mid-maturity doing a little bit better. And as we get to June, you're seeing the early maturities bring in more absolute yield than the mid and later maturity group. If we break this out to percent of maximum yield for each respective maturity group, again, the early denoted in blue, the mid in orange, and the gray being late. And you kind of see that crossover. So again, showing that late maturities did good with our early planting. Saw a drastic yield penalty with early maturities going on with those early planting dates. Here they're getting pretty close. There's a little separation there for that April planting date, but as we get through our May planting dates, they're clustered pretty close together. And as we get here to our June 10th planting, you can kind of see our early maturity is doing a lot better for percent of maximum yield, relative yield, with the mid and late maturities kind of clustering close together here. So just showing you the same trend we saw early on, but just putting it as a percent of maximum yield value there. So again, why is that? We talked about it's important to get the V3 to start flowering. And if you think about night length, again, shorter maturities need shorter nights to flower, where longer maturities will need a longer night length. And here we got three cities with distinct difference in latitude. So Blytheville, Arkansas being the most southern, and Madison, Wisconsin being the most northern. So if you look at Madison, Wisconsin, this gray line here, you can kind of see the duration of night length is shorter, but you can kind of see here that they have longer days during around the summer solstice, which is June 21st. Again, if you look here at Blytheville, you can kind of see shorter days, but we're capturing more total daylight throughout the growing season there. So if you think about when a 2.8 would start flowering, again, if we're thinking more of a typical planting date, it's going to be closer, to that summer solstice because it takes shorter nights. It doesn't take as much night to start flowering. Where if we plant, getting mid-May, to June planting dates with a typical maturity we'd use in Arnsville, that's going to come in a little bit later. Roughly, you're talking 9 days later. And one key thing to point out is that for every 10th change, 0.1 change in maturity on a variety, you can expect about a 1.2 day difference in harvest. So again, you got a 0.9 times 1.2, that comes out about to 11 days, and that's kind of what we're seeing there. Now let's do the opposite. If we plant soybeans really early, we got a great growing season, what would happen? So if we get those plants, we get plenty of growing degree days. What could happen is that they could start flowering before the summer solstice and kind of early that flowering window up. So what would happen if you plant a 2.8 and 3.7 at the same time frame? Let's say we're planting early April. What can happen? They can start flowering pretty close to each other because if we get early enough and we capture the night length that we had on this backside over here, that 3.7 will start flowering. And again, we'll be meeting that 2.8 criteria as well. So essentially, you wouldn't see much difference between a 2.8 and 3.7 if they're planted early and you have great growing conditions to get them there. Now, if we plant them early and it's cold and wet and that, the time to get the V3 is delayed, that could be pushed behind the summer solstice theoretically if that happens. And that could be kind of explain what happened here in 2019 as well. One key thing, just because we flower, realize that soybeans will abort pods pretty readily. So if they run into any stress, they will abort those pods. And just because you're flowering early, just realize that you're not home free. You got to get close to R5 and start filling those out to get closer to your yield potential. But the name of the game is, the more pods you set, the higher your chance for having higher yields, which kind of explains what happened in 2018. Here we're looking again some data from Dr. Navziger out of University of Illinois, and this was from 2018. And I want you to pay attention to these stars. This is first flowering. So we have two different planting dates. We have an early and more of a typical maturity for that area. Here we got a little bit later, beans planted end of May, 2.3 and 3.6. And if you look here between the 2.3 and 3.6, you can see here if we look at when they begin flowering, they're pretty close to each other. Now if we go to a later planting date, look at those blue bars, you can see there's a lot bigger stagger as when those start flowering. So again, you don't need as much night length for a 2.3 to flower. And actually, if you do plant the early maturity late, you can still flower before the solstice because it doesn't take as much night length to do so. But the trade-off is that soybean plant has to manage that vegetative and reproductive growth because it's indeterminate. So that's a fine balance. It has to go there. And realize that once you start flowering and you get to R5, all vegetative growth will stop. So once you start to flowering, typically you have 35 to 45 days to get all your pods set. Here, if we look between our first flower to start a pod fill, again, R5, you can kind of see with this early planting date, early maturity, that window isn't as long. But here we're in that 35 to 45 day with those later maturities, or with those later planting dates. Between the 2.3 and 3.6, and a longer maturity there, planted end of April there. So the take home, so like what we saw, the recommendation is that if you're going to plant early, maybe you should try going maybe a 0.5 maturity group a little bit later. And that kind of goes with what we're seeing in line there. So if you get that early enough, you can start flowering early and wrap up that later maturity a little bit earlier. Again, you're not going to see as much of a drastic difference in flowering date with early planting between early and the more normal maturity groups. And again, V3 is key. I want you to remember that, 3 trifoliate. So weather conditions play a major role in the yield advantage you might see with early planting. If we have bad weather conditions and that delays that growth, you're not going to capture that yield advantage. You know, maturity diversity is a good thing. So if you look, you know, having a range of maturities, and there's some good soybeans and certain maturities, using a diversity of those is a good thing to spread your risk around. I know a lot of guys get caught up in maturity, but realize each 10th difference in maturity group is 1.2 days difference to harvest. You know, when you're doing your planting dates, you probably want to switch up your maturities. Again, plant a little bit longer, going into those early April planting dates, and as you get into May, kind of switch into your normal planting dates. And the key is as you get later, really bump up your population, because those plants can get shorter. We want to get those pods off the ground. Again, it has to balance the flowering and the vegetative growth there. And sometimes with those later planting dates, if you don't increase the populations, maybe 25%, you can see you have shorter beans, and they're hard to get into that soybean head there. Again, once the flowering starts, you got about 35 to 45 days, you know, from flowering to pod fill. And realize that vegetative growth will cease at R5. And the name of the game is the more nodes equals to increased pods equal to increased yields if weather conditions hold true. So I hope you got some information to think about soybean maturity and planting dates. Again, this is from 2019. Hear a lot of growers saying this is a unique year for sure. But this gives you an idea of what we experienced and how it kind of plays to the weather we saw in 2019. So with that, thanks for listening and enjoying this presentation. And if you have any questions, you can feel free to reach me at Dana Harder at burrusseed.com. Thank you.